Hello students, so my name is Prithvi and I'll be explaining you atomic absorption spectroscopy. So why are we studying this? So this is one of your topics, indirect topic in advanced forensic chemistry syllabus. When we have topics like checking the concentration of particular element, okay, whether this element might be present in the form of adulterant or in certain drugs when quality checks and all are there, when we have to determine the concentration of a particular element, metallic element, or what kind of metals are present. Okay, so that time we can use. Okay, of course there is n number of techniques. For example, if you want to check the quality of gold, okay, gold is adulterated, okay, with the copper or some other metals, okay, silvers and all. So now we have n number of chemical reactions which we can, you know, do and identify which type of adulterant is present. But we can only identify which type of element is present. That is qualitative analysis. But when we have to detect the concentration, there are certain cosmetics in which a certain, certain amount is affordable. Affordable in a sense that yes, it is allowed. But more than if the concentration exceeds, it's a problem. So in that case is when we have to determine the concentration. Okay, both presence and concentration. In those cases, we can apply the spectroscopic technique, whether it is atomic absorption spectroscopy or whether it is emission spectroscopy, to detect the presence of metal, also detect the quantity of metal. Okay, both concentration and presence. That means it is used for both qualitative and quantitative analysis. So of course it is having the forensic significance. Now forensic is something like it covers everything, whatever is present. Okay, there are many branches. Now suppose you have to check adulteration in food. We we cannot forget our favorite Maggie, right? So in that a certain level of lead concentration was present. So to detect that we were doing different type of analysis. So in food industry or to check the composition of drug or to determine concentration in cosmetics of particular element or to see what is the mercury level in a in suppose XYZ cosmetic. We can use this technique atomic absorption spectroscopy. Clear? Now in this topic we'll cover instrumentation, working and principle, application and forensic significance, not in lengthy text because I know that is all present already present in the Google. You can type and get the best notes from the best websites. We are going to understand the concept in very basic language and very easily so that we can retain it, right? So this is your instrumentation part. You can see sample is there, light source is there, flame is there, whatever you can see, detector and all. We'll try, we'll break down into each component and we will study. Okay, before starting, I must choose a blank slide. Yes, so when we are studying spectroscopy, we should know what spectroscopy is. Now, obviously, you are going to have very good classic definitions of spectroscopy, but what is the basic spectroscopy? If the word comes, what definition comes to your mind or what is the actual meaning of spectroscopy? In simple terms, spectroscopy is the interaction of matter with EM waves. Suppose this is your matter and this is your EM wave. Okay, this electromagnetic radiation is interacting with matter and the study of interaction of matter in electromagnetic waves or radiations is known as your spectroscopy. We are actually studying what is happening when this EM wave or EM radiation is interacting with matter. So suppose this EM radiation is interacting with matter. Now there can be three cases. Okay, what is the first case? Matter must like EM so much. Okay, These are of opposite genders. Just consider that matter must like EM so much, so it might completely absorb it. Okay. Now suppose matter develops a huge crush on the EM radiation. So starting now what happens? Going to like so much, it becomes excited, and then when he understand about practical things and know it's not going to work, so again it will move towards the stability and release what? Energy. Okay. So either this matter is going to absorb it, or this matter is going to absorb this particular electromagnetic radiation, become excited, and when it will come back to the normal stable state, it will release it. That can be known as your emission. Or suppose the matter is not at all liking this इलेक्ट्रोमैग्नेटिक रेडिएशन, उसके काम का है ही नहीं, उसका वेवलेंथ को अब्जॉर्ब नहीं कर सकता, एब्जॉर्ब नहीं कर सकता तो एमिट भी नहीं करेगा, राइट? So what it will do, it will reject. So the rays, no interaction will happen. When no interaction happens, the EM waves pass away. That is known as your transfer. So this three phenomenon can be observed. First one is absorption. It might absorb, it might emit, it might reflect the rays back. Okay. So what is EM? What is spectroscopy? Interaction of matter with electromagnetic radiation. Till here clear. Now we'll start with the instrumentation part. Okay. Now in this instrumentation part, you can see the first one which is given is hollow cathode lamp. Now this hollow cathode lamp is the radiation source, and we are individually and focusing in this hollow cathode lamp, because if you are going to understand this, the entire instrumentation part is going to be easy. Now this hollow cathode lamp, if I draw it, sorry for my bad diagram. Okay, sorry. Now here we will see that one cathode is there, one anode is there, and of course high voltage is going to be applied. Okay, so then there is certain things happening, we'll see. Now here in this diagram you see this is cathode, this is anode, and this cathode is made up of metal of interest. Now this is the important point, and you have to remember this very precisely, that if we are detecting the presence of lead in magnet, our metal of interest, okay, is going to be lead. That means the cathode in the hollow cathode lamp is going to be made up of lead. If we are checking the mercury level in the cosmetic, our cathode material is going to be made up of mercury. Got it? Okay. So for example, here we are just taking the example of sodium. Okay. In an entire topic, we'll deal with sodium. Now here our metal of interest, that means this cathode is made up of sodium. Here is cathode, here is anode. High voltage is applied. This voltage is very high, nearly about 10,000 volts. Okay. Now what else? You can see this is not vacuum. This lamp, okay, this is not vacuum. Inert gas is actually filled in this. Inert gas. Inert gas. So suppose neon is filled in this. Okay, neon as an inert gas is filled in this. Now what will happen when we apply the voltage? When we apply the voltage, what will happen? These molecules of inert gas will become charged or will get ionized. And these molecules are going to be very, 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 very fast moving. Okay. Now here the inert gas molecules are there. It will get ionized and it will, move very fast. Now these fast moving ionized inert gas molecules will hit the cathode. What it will do? Will hit the cathode. Okay. So there will be interaction of these molecules with cathode. Okay. Now what will happen? This cathode is made up of sodium. So some atoms of sodium might get absorbed, might get excited. Okay. It might also get charged, and what will happen? Suppose sodium is there, sodium will become excited, it will get ionized and again come back to the normal form. So it will emit here the energy. Are you understanding my point? Inert gas is there, cathode is there, anode is there. After applying the voltage, what will happen? This inert gas molecules are going to be ionized. Now these ionized molecules are going to hit cathode and some atoms of cathode might get excited and get released. Now I'll make this sodium metal with some different color, okay? Then you will understand. So this is your sodium atom and coming back to our favorite red, this is our inert gas, okay? Now what will happen? So again, we will revise it. What happened? Firstly, voltage is applied and because of the voltage, this inert gases are going to get charged or will become ionized and fast moving. Second step is what? It is going to hit the cathode. Hit the cathode. After hitting, there will be certain kind of interaction. It will become excited and all that kahani you have understood. Now, these sodium metals, these sodium atoms are going to be released, will get released. And this releasing of sodium atoms, okay, this releasing of particles of cathode because of charged ionized gases, this method is known as sputtering. What is this called? Sputtering. So this method is known as your sputtering. Yeah. Now here lens is applied. Now okay, what will happen? Suppose, as I told you, sodium getting ionized. Okay, sodium is getting ionized. Now during this process, what will happen? It will, yes, and it will come back to the stable state. It will release. It will release a certain kind of wavelength, and these wavelength is going to be characteristic to sodium. You remember photoelectric effect? Different concepts you are studying in 12th class. Okay, so the sodium is going to release energy and this energy will be characteristic to that particular atom. हर एटम ऐसे कोई भी वेवलेंथ एमिट या अब्सॉर्ब नहीं करता, एक पर्टिकुलर वेवलेंथ होता है. So suppose it is emitting 589 nanometer or 598 nanometer, just check. So this is the wavelength that is getting released in the form of radiation. Now these wavelengths, this light, this electromagnetic wave is going to be your light source. Now here, this excited particle, because of this excited particles, wavelength is emitted and this 590, 589 nanometer wavelength sodium is going to emit, which is further going to be your light source. This lens is just there to focus it. Okay, the use of lens is to focus. Now the next part is your sample. This is your sample. Okay. Now in sample you have to understand one thing, that whatever may be the sample, whether it is liquid, solid, gas, ultimately the sample in atomic absorption spectroscopy, the sample should be in gaseous form. So whether it is liquid, it has to be converted into gas. Whether it is solid, it has to be converted into gas. So solid is there. We have different methods, different other methods like laser treatment is there. We'll treat it with laser and it will sublimate into gas. Now here we are taking a liquid sample. And we have to first convert this into gaseous form. Now this sample will inject our sample and this sample comes to nebulizer. This part is your nebulizer. This entire part, this entire setup. First one is your electron gun or radiation source. Second one is your atomizer. Atomizer. Okay, it converts liquid into gaseous atoms. Now here our sample is there. Okay, now this is in the solution form. It will come to nebulizer. In nebulizer what will happen? This sample will mix with oxidizing agents. See, oxidizing agents and fuel. Okay, because we need this flame to burn continuously. For that we are needing this oxidizing agent. Clear? So this liquid sample will come to nebulizer where it will get mixed with fuel gases and oxidizing agent, and further, and this oxidizing and fuel, this oxidizing agents also serve as a fuel so that the flame burns continuously. Now the sample will come here mixed with oxidizing agents, and then due to this high flame, it will convert into gaseous molecules. So this step is known as your volatilization. Volatilization. Now after volatilization, what will happen? Now see here, the first step is your volatilization. Now in volatilization, what is happening? In volatilization, what is happening? Liquid is getting converted into gas. Now we have gaseous molecule present here. Now see here your wavelength of 589 nanometer is coming. Okay, now what will happen? If in the sample, this is your gaseous molecule, if this gaseous molecules have sodium concentration in it, it is going to absorb. Okay, it is going to absorb this wavelength. If suppose it has some Na particles, this Na particles is going to absorb this radiation of 589 nanometer and get ionized. And this is our sodium molecules, okay? Sodium gaseous molecules. And rest all are your different other gaseous molecules. Now sodium metal will absorb, and rest all the radiation will be passed as it is, which is not absorbed. Now these radiation will pass through a grating system. This is known as your grating system. It might have chopper, it might have monochromator, it might have series of mirrors and prisms. Okay, we are not going into the setup in detail, we're just looking at the overview. So now this remaining radiation, which is not absorbed by sodium, is going to travel from your monochromator, and detector here will get the signals, and these signals are very small, so it will be amplified so that we can read the output. Now here what we are reading, our reading is not of absorbance, our reading is for transmitted light. As I have told you explained you the concepts, the light or the radiation which is not absorbed is known as transmitted radiation. So here whatever sodium is absorbing, it is absorbing, and rest all will be transmitted. Now our detector is going to detect this transmitted radiation, and we will see the result as transmitted. But now we have different softwares which can automatically convert transmitted into absorption. What is the relation? It's the inverse relation. Relation between transmittance and absorption is inverse. That is very evident, right? Whatever is not absorbed, that will be transmitted. Hope this part is clear. So we'll just revise one. We're just looking at the overview. First one is your hollow cathode lamp or radiation source. Second one is your flame atomizer. Here we are using flame atomizer. Then the rays which are transmitted will be detected by the detector and will get the readings. Okay, and we have to convert this into absorbance form, which is automatically done by this software. So this is your absorption spectroscopy. So very important part. Now this part we have discussed. We also have to see how it works. So working in principle you already understand. Work principle for any spectroscopic technique is going to be same, whether it is mass spectroscopy, whether it is absorption, UV visible, anything. It is going to be Beard-Lambert's law, according to Beard-Lambert's law. Clear? Application we have to discuss. We have already seen the application. Okay. If we talk specifically about forensics, there are many cases. When we have to see here, okay, toxicity or drugs effect, poison effects. We pluck hairs and we analyze it. So there are many cases where we can use this technique and study the concentration of metal, how much it is present. Different cosmetics have different, unwanted metallic components in it. So for detecting all those things, we can use this technique. So hope atomic absorption spectroscopy overview is clear to you. In next video, we'll discuss the in detail. Okay, now how it is calculated, what is the relation between transmittance and absorption. Okay, the log value and how the graph is plotted, how we run a control sample, and how we calibrate the curve. This all we'll see in the next video. Thank you so much.